Hello students, welcome to another very interesting section. I'm Sufian Babatunde. I'll be taking you BUS406 Analysis for Business Decision. Our last class, we discussed on transportation model. But let's look at assignment model, where we'll be talking about objectives of assignment model, types of assignment model, and also we'll look at sample on how to solve assignment model mathematically. And I assure you, you will enjoy very interesting lesson. Hello students. Let's look at lesson 2 on BUS406, Analysis for Business Decision. I'm the facilitator of this course. My name is Sufian Babatunde. Today is October 7, 2020. Now, let's look at the outlines of the topic. We have introduction, assignment model, objectives and types of assignment model, Hungarian method of assignment model, and we look at the exercise. What are the assignment model? This is the introduction of assignment model. The assignment model deals in allocating the various items, that is resources, to various receivers, which is the activities, on a one-to-one basis in such a way that the resultant effectiveness is optimized. Let's look at the definition of assignment model. It's a special case of transportation problem. In this problem, supply in the matrix table represents the availability of a resource, such as man, vehicle, produce, and so on. What are the objectives and types of assignment model? Objective: 1. No workers is more than one job. 2. No job is allotted to more than one worker. Then 3. Total time taken to complete a job is minimum. 4. The work done is cost effective. These are the types of assignment model. We have two different types of assignment model. One, we have balanced assignment model. Under the balanced assignment model, it consists of a square matrix, that is column multiplied by row. That is number of rows equal number of column. Then the second one is unbalanced assignment model, where it consists of a non-square matrix, that is the number of rows not equal to number of column. Let's look at the Hungarian method of solving assignment model. An efficient method for solving an assignment model, known as Hungarian method of assignment, based on the following properties. 1. Is an assignment model if a constant quantity is added or subtracted from every element of any row or column in the given cost matrix. An assignment that minimizes the total cost in the matrix also minimizes the total cost in the order. Then 2. In the assignment model, a solution having zero total cost is an optimum solution. It can summarize as follows. These are the steps that we need to follow in solving assignment model. Step 1. In the given matrix, subtract the smallest element in each row from every element of that row. Step 2. From the reduced matrix obtained from step 1, subtract the smallest element in each column from every element of that column. Step 3. Make the assignment for the reduced matrix obtained from step 1 and 2. Step 4. Draw the minimum number of horizontal and vertical lines to cover all zeros in the reduced matrix obtained from step 3 in the following way. Let's look at the way. A. Mark all rows that do not have assignments. B. Mark all columns that have zeros in marked row. That is step 4A. C. Mark all rows that have assignments in marked column in step 4B. D. Repeat step 4A to C until no more rows or columns can be marked. Then let's look at E. Draw straight lines through all unmarked rows and marked columns. Let's look at step 5. If the number of lines drawn in step 4C are equal to the number of columns or rows, then it is optimal solution. Otherwise, go to step 6. Let's look at our step 6. Step 6 says, select the smallest elements among all the uncovered elements. Then step 7, go to step 3 and repeat the procedure until the number of assignments become equal to the number of rows or column. Let's look at example of balanced assignment model. Let's solve the following assignment model to get maximum profit. This is the question. These are our profits. 1, 2, 3, 4. This is the plant A, B, C. If you look at it, we have 4 columns and we have 4 rows. That is balanced assignment model. Let's look at step 1, which is the row reduction. And step 1 says, select the smallest element in each row and subtract it from every other corresponding element of that row. If you look at this question now, the smallest element in this first row is 1. So we now subtract this 1 from every other element in that row. Then we now have 1 minus 8, that is 7. 1 minus 9, we have 8. 1 minus 4, we have 3. 1 minus 1, we have 0. Then row 2, the smallest element is 5. 5 minus 6, 1. 5 minus 7, 2. 5 minus 5, 0. 5 minus 8, we have 3. Then row 3, the smallest element is 3. 3 against 4, we have 1. 3 against 3, we have 0. 3 from 5, we have 2. 3 from 12, we have 9. Then the last row, we have 1 as the smallest. 1 minus 1, 0. 1 minus 3, 2. 1 minus 6, 5. 1 minus 3, we have 2. This is our row reduction in step 1. Let's look at the column reduction. From the reduced matrix obtained in step 1, let's get our column reduction. This is the step 1 that we just did. Then the column from this step 1, we transform it to the column now. This is the smallest element in column 1, which is 0. This is the second column, the smallest element is 0. The third column, the smallest element is 0. Then the fourth column, the smallest element is 0. If you minus 0 against 7, against 1, against 1, we arrive at 7110. If you minus 0 against 822, we have 8202. If you minus 0 against 325, we have 3025. Then if you minus 0 against 392, we have 0392. Now, let's move forward. Let's look at horizontal and vertical lines to cover all zeros. This is how we can make our assignment now. In our question, we have 4 rows and 4 columns, and we need 4 lines in either row or column. This is the first line, this is the second line, this is the third line, and this is the fourth line. If you look at the line, all the lines pass through what? Zeros. If you look at it. Now, let's look at the step 4 to cover our 0. And step 4 says we need 1 0 in either row or column. If you look at this first row now, we have 1 0. If you look at this column now, we have 1 0. So we have to box this particular one. Let's look at the row 2 now. This row 2, we have 1 0. This same 0 fall under column. So we box the second 0. Let's look at the row 3. We have 1 0 here under 2 profits. So this 0 fall under row and also fall under column. Then the last one, we have 1 0. This 0 fall under row and also fall under column. So that means we have 4 zeros in a line. We have 4 lines. The number of row is 4. The number of column is 4. Now, let's look at the optimal solution. This is the optimal solution. A4 we have 1. B3 we have 5. C2 we have 3. D1 we have 1. Give us the total of what? 10. Let's look at the summary of what we have done so far. Assignment model is a special case of transportation problem. It deals with allocating the various items to various activities on a one-to-one basis in such a way that the resultant effectiveness is optimized. In this lesson, we have solved balanced assignment problem using Hungarian method, and our next lesson will look at unbalanced assignment model. Thank you for listening.